Welcome back to another episode of Automating Minecraft. This is a series where I use code to automate tasks in Minecraft, hopefully in a way that doesn't bore or push away people that don't know a lot about programming. Now, the code I write only has access to what a player can access, so it can press my keyboard and move my mouse. It can also kind of see what's on my screen, and I have some techniques of it so it can kind of understand what's happening on it. But it's not directly in the Minecraft, so for example it can't see something that's not on my screen or move my character in a way that the game doesn't allow. This is a part 2 from the previous episode because we didn't quite get everything done last time. Now if you haven't seen the last episode, or it's been a while since you saw it, I'll make sure to briefly explain what happened last time when it comes up so you aren't completely lost. So today we're in my testing world, which is why I'm in creative mode. But we will be getting this working on the survival server by the end of the episode, and you have my promise this time. So we're attempting to have a program that automatically places all the mud on these drying platforms in my brick and terracotta factory, but in the last episode we did get a solution, but it was very slow and also very unreliable. I made a lot of mistakes when moving across. Sometimes it would just not detect that it should place one there and kind of skip one, or fall off blocks when it's moving forward, or when it's moving back, or fall down here. It did a lot. Or when it's kind of moves back along here because it didn't place one, it'll fall down into these gaps. Things like that. It was very inconsistent and also very slow. Oh, also, if you don't know, if you put mud on top of dripstone like this, it'll eventually turn into clay, and then from clay you can then make bricks and terracotta. Now this episode is on this episode of Automating Minecraft. Oh, I forgot we had this. Thanks, Dave. Some very exciting things happen. It works! It works! Woo! Bobbywar explodes! Wait, what? What? No? Man, Bobbywar gets chased by a flying camel! No, Dave, it's supposed to be things that are actually going to happen. None of that is in the script. It's not going to happen and they'll be disappointed. Increase watch time, but why would they come back for the next episode if they're disappointed with the last one? No, it's okay, Dave. You'll do better next time. Okay. Anyway, now there are a lot of things that I've been testing since the last time, and as you may be able to see, there's a lot of stuff that I've added here, and I have some people to thank in the comments. Firstly, someone said that I could position myself more precisely if I used a boat, so I now have a boat. So when we start the program, it's just moving in a set way, so it doesn't make any decisions by itself, which means they have to start in exactly the same position each time, and boats orientate you in the direction they're facing when you get into them. So I can show this off if I pressed F3 and B. We'll be able to see hitboxes and also the direction that the boat's facing in is this blue line. So if I get in the boat from down here and I face in the opposite direction to what the boat's facing, you'll see that when I get in the boat, I'm facing in the direction. I was still looking up, but I'm facing the direction the boat's facing. So look at that. Boop, I flip round. So with this boat, if I kind of get onto it and then I line myself, don't want to move it. If I line myself up so I'm perfectly straight with the block, you'll be able to see that that black line, that black outline of the block is straight horizontal, and the boat's line is pretty much straight vertical. So the boat is perfectly straight. And you might have also noticed I've added these trapdoors. These are also to line myself up. That was also a comment, so thank you very much. So the boat does my camera and the trapdoors does my position. So what I do is I line myself up with the boat with my camera, and then I push myself into this corner so we know we're exactly in the same position each time. These command blocks here are just to remove anything on this platform. They'll just do the same thing. And I've just got pressure plates on some of them, just depending on where I am and kind of what's easier at that time. And if I feel like pressing a button, I've got the button up here just to make it really easy for myself. Now that that's all out of the way, we can move on to what I've actually been doing, and I'm very excited to show this off, which might be a spoiler on how this process is going. But if I jump on the boat and I just look down and then get out, and I stop touching my mouse, and then line myself up with the trapdoor like that, so you can see that the block outline is perfect. And then all I have to do is press numpad 3. Oh, wait! This is also something I learnt from the comments. Now this is going to probably take me a while to explain, so if you're not like me and don't find how computers register numpad buttons interesting, skip to the time on screen. So when I first wanted to have the program start when I pressed the number pad buttons, I wasn't sure if the number pad buttons registered as different buttons than the numbers across the top of your keyboard, and the answer is they do, actually. Even though when I press number pad 3 it types a 3, my computer sees those two buttons as two different inputs. So I looked this up and I found the solution that I used last time. This was by giving the code that I used to detect keyboard presses the mysterious number 81, which correlates to the number pad 3 button. This worked, but as someone pointed out in the comments, it would also work if I press the page down button. This is because number pad 3 can be used as a page down button with the number pad off, and so the program that I was using just saw them as the same thing. This confused me, because my computer must be able to distinguish between these two buttons, because I can press number lock and have the number pad 3 work differently, but page down always works the same. So are keyboards more complicated than I thought? Does the keyboard have a circuit that sends a different signal depending on if the number lock has been pressed? No. What was happening was the code I used to detect keyboard presses looked at what should happen when the key is pressed, not what key is being pressed. So if I press number pad 3, it will say page down when number lock is off, and it will say 3 when the number lock is on. To fix this, I'm using different code now that looks at actually what key is being pressed. So now it only works if I press number pad 3. I just thought it was interesting. Anyway, let me go and line myself up again and show off. Number pad 3. And there we go. Like last time, it goes and shifts and places the first row. But then when we get to the end, it should do something differently. There we go. You'll see it moves forward and then very quickly goes and places the next row. And it'll look down and move forward and then place the next row. So it's a little bit slow when moving forward, but apart from that, it's very quick. Now, I will be going over how exactly this works right after this, and this does still have a few problems, but can get to the end without errors, or near enough to the end, which means like within like 3 rows or something. It's pretty good, is what I'm saying. And if it makes an error, it can kind of correct itself as well, and I'll kind of go over how it does that. There are some problems, like you might have seen on the windows, there's some birch wood. That's because if that wasn't there, it would just walk off the edge. It's just not quite precise enough in that movement. So we are going to have to implement something that means it can detect when it's at the edge, rather than that it's a time thing. Oh, there we go. So there we go. That's one time when it can go wrong, but normally it goes and corrects itself like that. So we will now be 1 row back from the end, but obviously that's much better than it just completely 2 rows back from the end. Sorry. Oh, it's not doing amazingly, but it will correct itself like it did there. But as you can see, it failed twice, but that only means that it gets 2 away from the end rather than we were like back here and it fails. So for the code, it just works in the same way as we've done previously. I just write a name and then say copy the code that we wrote in episode 1, just so I don't have to write it over and over again. With the actions down here, I've moved into using the code how it was intended. Last time I was saying that I was writing in a way that I didn't intend in the first episode, which was to have the code make more decisions rather than do things in a set way. So instead of moving down these list of instructions like this, boop, 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 within time, what it did, it was running 1 until a condition is met. For example, it would walk left until there's an empty space, and then it would move on and place mud, rather than working in a time system where at time 0.0 it runs this, at time 0.2 it runs this, at time 0.6 it runs this. So these first set of instructions are just to place the first row, so it presses space, so it jumps, then it holds down the right mouse button, presses shift, and then presses A, so it moves left. After that, it walks forward until there's no clay or mud. So I've got the instructions for the next 15 rows. So what I've done here is added what is called a for loop, and as you can see, it's got the number 14 in here. This runs 14 times. So the first one I've actually built outside of this. Here, this is this code, because it was easier to test with kind of getting it right with just 1 and then kind of just copying the code for the 14 more. What it does is it first looks down until it can't see green, so that presses F3 and then uses the X, Y, and Z lines in the middle of the screen to determine where it's looking, and it moves the mouse down until there's no green line, which is the Y line, which points up. So if you look down, it will disappear. Then it walks forward until there's no mud or clay. Then it calculates if it's either should be moving left or right. So this is done by getting this looks very complicated. So pretty much I is the kind of row we're on. So it gets I, it divides I by 2, and then if I doesn't have a remainder after being divided by 2, it then knows we're going left. If it does, then it knows we're going right. With every even number, it goes left. With every odd number, it goes right. I hope that makes sense. It's a little bit confusing. So then it presses either A or D and then holds down the mouse button. And then we've got this code which updates the start time where these instructions should start from to the end of when these instructions stop running. So then when it runs again through this for loop, goes and adds the instructions for the next row. The next row starts where the last one ends. Now I want to go through some of the more interesting code. Now to do this, we're not actually going to look at the code, but I'll make visual examples because it's going to be a lot easier to follow. So if I head up here, we've actually got this move mouse Y to average point, and this starts after the first row's been placed and goes up until the end of the program. So this is the time when the program finishes, so it's constantly running for the entire thing. And what it does is it moves the mouse to the center of the block that it's looking at. So if I head into the game, I'll show what this means. So we had problems in the past with the program not aiming in the correct space and trying to place blocks at its feet or on the next row. So like if it's like done with this one, it should be placing here, but it's actually placing on this row. To fix this, what I've done is made the program always aim for the center of this block. So if the program's always aiming for the center of this block, it's actually less likely to kind of be aiming too high and then slip over and then be placing on this next row, or be aiming too low and then accidentally move onto here and maybe moving across like this. But how do you make it look at the center, you might be asking? For this, I'm going to have to build a graph. We all know graphs, I assume. There's an x-axis and a y-axis. So let's imagine that this graph here is the screen, and each pixel on the screen can be mapped to points on this graph. So let's put the block outline on the graph. So there we go. So when I look at a block like this, the computer sees this black box around, and that's what this is showing here. So if I get all the coordinates for each point in this square, like this, and then if I go and get the average x coordinate of all these points, so that's the first number and correlates to these numbers down here. So this is the mean average, so I add up all these numbers and then divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So add them all up, divide by 12. So if I do that, I get 4.5. And if we look at where 4.5 is on this graph, it'll be in between these 2 points. And if we go up, we will see that it is the x-coordinate of the point in the center of this square. And if I do the same for the y, we get 3.5. So if I look at the graph and go to 3, and then halfway between 3 and 4, we will see that it is also right in the middle of this square. So if we move the mouse towards this average x and y coordinate, my character is always looking at the middle of the block outline. You might have also noticed that my block outline is a little bit thicker than normal. That's because I'm not sure if the normal outline is completely black, but what I found was I was using the RGB method, and I was just looking for 000, which is completely black, and it wasn't detecting anything. So what I did was I found a website, in which I'll link in the description, which allowed you to change this color and the size of this outline. So I made it a little bit thicker and also made it completely black, and that means that it now has no problems detecting it. So this walk forward until no mud or clay is something that we've seen before, but I've changed how it works a little bit. What it does is it moves forward until the code doesn't see a lot of clay or mud in the center of the screen. So we know we're looking at the next row, which will be in spruce. Previously, I was using the RGB value of the color to determine if the color was on my screen. So if you don't know, pixels on a screen are made up of a tiny red light, a tiny green light, and a tiny blue light. And our eyes interpret those lights at different brightnesses as different colors. It's very strange, but it means that I can specify a red, green, and blue brightness and say to my computer, get me all the pixels that are at those red, green, and blue brightnesses. The problem with this is that it's too specific, which means that if the block gets darker or lighter, like if it turns to night, it will have a different RGB value and no longer show up. So I'm using a method of storing color values that is closer to how we humans understand color. So if I come into the game here and I place down some mud, we can see that this mud is what we would call mud colored, right? And we understand that if I move down here and place some mud, we can see that it's still the same color, it got darker. So this is just a darker version of this color, and this is just a lighter version of this color. This is where HLS helps out. This uses the hue, saturation, and lightness to store what the color is. Now I'm going to link a video by Nice Name, I think that's how you say it, which looks at RGB, HLS, and HSV color spaces, and it explains them better than I can. Pretty much HLS has us define the hue and saturation, which is like the actual color, and just change the brightness or lightness as it's called here. We get the color of mud and just have the program ignore the brightness value, so it doesn't matter if the block is up here or down here, it'll work the same. I've also changed the way that it detects how much mud is on the screen. With the previous method, it just counted how many mud-colored pixels were on the screen. However, this can still change a little bit through brightness. What I found was more accurate was finding the first point where mud-colored pixels appear. Then we can see how much spruce is on the screen. So if it's like this, and we move up, you can see that where the first mud-colored pixels will be detected will get lower and lower as we move forward, until the mud is so far down and we're looking at the spruce. So I think that's everything. The thing I need to add now is the ability to detect when I'm at one of these edges, and I've already written the detection code, which I'll show off now. Okay, so what I've put on the screen is all the pixels on my screen which are jungle wood colored, and you might be able to see that it doesn't quite look right. This is only on the left side of the screen, by the way. So we can actually show maybe it off a little bit easier. If I kind of just block up this, or like build like a weird shape like that, then we'll be able to see oh, this is difficult to position, that you see there. So now we can see on the screen that's over here, this part. So you might say, well, that looks like it's on its side. It is on its side. And I'll explain why right now. So like I was saying before with the mud, where we can detect how much mud's on the screen by going up and seeing where the first mud pixel shows up. We can do the same with the left side of the screen if we flip the image round. So if you see, it comes up from the bottom rather than from the side, and that makes it much easier to detect because it's the same as with the mud, where it's exactly the same code. So now all I need to do is have it detect when I get to this side, and when I do, move forward and then start placing the next row. So I've got that implemented, and I'll show it off now. Now there are still a few problems, but it gets close enough to the end that I'm happy with it. I'm going to be making an improvements video where I look back at all these programs and use what I've learned throughout the series to improve on them. So I'll look at this program again when I do that to see if I can fix any of the small problems it has here. So there we go, and then when it gets close to the wall, it stops, looks down, and moves forward. Now you might have seen that when it got closer to the wall, and you'll see this side as well, it starts to slow down. This was another suggestion from the comments, so thank you very much again. The problem is, when the screen is changing faster than my program can see that it's changing, it can't respond in time. So I end up just falling off the edge because my program hasn't seen the wall yet. But by slowing the movement of my Minecraft character down when we get closer to the edge, means that my computer has more time to understand what's going on the screen and stop if we get to the edge. Oh, there we go. It can still do that, unfortunately. Like I say, we'll go and have a look at those little things in the improvements video. And this may be also a little bit of a problem, where because it detects jungle wood at the top of the screen when it's on these last rows, it can slow down even though it's not very close to the end. But as you can see, it made it all the way to the end minus one row. But I think in that we did miss out one row, or did kind of fail to do one row. There's also a problem that didn't happen here, but does happen sometimes, when the program will end, I think like maximum about 3 rows back. And this is a problem that I don't know how to solve, and I don't really have the time to look into right now. It's not a big problem. The code still gets close enough to the end, like I say, within 3 rows, that it's fine. But it might be something to look into in the improvements video. But the problem is there seems to be a limit on the amount of times the code that looks at my screen can look at my screen. I don't know why this is. I have had this problem before while testing what colors are being detected, but always thought that I don't run the program long enough for this to ever be an issue. But now I do, so it just stops working and displays an error. I've tried writing some code that kind of ignores the error and just tries to look at the screen again until the error goes away, but I left it running for a few minutes and the error never went away. The program has no problem if I just restart it, but for some reason it doesn't like to be running for too long. But that happens so close to the end that I don't really mind. And like I say, we can have a look for a solution when we do the improvements video, so we can get it fixed then. So the final thing the program needs to do is detect when my hand appears, because that means I've run out of clay, and then if that happens, look down, middle click, and then look back up and continue. And then if it middle clicks and my hand is still empty, then the program should end because I've run out of mud. So this section is a little bit more complex than I thought it was going to be. Firstly, there are actually two conditions that we need to check for. They are when the program stops when the screen is looking at mud, so it's moving across like this and it detects there's no hand here, or when the program's looking at spruce, like the block next to it, then it realizes it's got nothing in its hand. This is just because of the speed of the program. Sometimes it detects it when it's here, sometimes it detects it when it's here. If it is looking at mud, it just needs to detect that it's looking at mud and then middle click. But if it's looking at spruce, it then needs to move back until it sees mud, middle click, and then move forward again until it sees spruce. So I've kind of got that all working, but there are some problems with it. If the mud is quite close to the center of the screen, like if it's like here, it might just detect that there's mud there, and obviously we can see where I'm looking at spruce, and then try a middle click, and then it either ends because then there's nothing in my hand, or if I have spruce, it will go and place the spruce down. But there's also a problem if the program moves back and this block is, oh, like that, and this block is clay, because obviously it will middle click on the clay, and then if I have clay in my inventory, it'll start placing clay, or if I don't have clay in my inventory, it'll stop. I could set it to continue moving back until it sees mud, which could work if I was like over here. If this one was clay, kind of move back, oh, there's mud, and then move forward again. But if I'm right here and this one turns to clay, yeah, that doesn't really work. And I could make it so maybe it like moves back if it doesn't see clay, it maybe moves this way or this way until it sees mud or something like that. But then the program's getting very much more complex, and it's taking longer and longer just to get mud back into my hand. Also, you might have noticed, and it might be a bit strange if you didn't notice, but I'm actually Yoshi eating Bobiwa. This was a skin I made for Games Night on this server, where we played a Mario Party inspired Minecraft map. And if you want to check out these Games Nights, I'll put a link in the description to Linus's Twitch channel, where they're live streamed every Friday and Saturday at 7 PM GMT. Linus is a member of the TDT server, by the way, and the TDT server is the server we're on. But the skin change here was because I had some problems with detecting my hand. For some reason, the program didn't like detecting my hand color, but light green is much easier to detect, so that's why I'm using this skin. That's just something we'll have to look into in the improvements video. Now I can show off the code how it is currently, but it will go wrong at about kind of here, halfway through. So if I go and get myself some mud, and boop, 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 there we go. And press 3, and obviously just continues as it would do normally. Oh, it failed there. Oh, it failed twice. Oops. It should hopefully correct itself. There we go. Wow, it doesn't normally fail this much. Wow. There we go. Right, so as you can see, it's coming up to the end of the mud that it has. It only has 4 left to place. It'll detect that it has no mud. It sees spruce. So then it moves back 1. And then moves back forward, or middle clicks the mud and then moves back forward, and then it'll place all the mud down. It failed again. It doesn't normally fail this much. Oh, what? Potentially could somehow these bubbles be affecting it? Oh, there we go, ran out of mud. I think there it detected, yeah, it detected that it was looking at mud, but obviously we can see it's looking at spruce just because it's close enough to the mud, and so that didn't move back. But even if it did, I mean, it would have got 1. But obviously it didn't. So we just tried to middle click the spruce and obviously got nothing. So yeah, like I say, about halfway there. So my other idea is maybe one that kind of works a little bit better as well. But the idea that I've had is if it opens the player's inventory and then looks at each slot to detect if it has mud in, and then if it does, let's say there's some mud like here, it'll go down, oh, there's some mud, it just shift clicks into my hand. I think that would be a lot easier because there's no moving and then getting back to like the perfect mud placing position, like looking down at this spruce, which will make the program a lot simpler. And also I think it'll make the program quite a lot faster as well, because it's not like having to, if I had to kind of have it navigate around clay and do stuff like that, the program's just getting too complex and taking too long. Also, what I think I'm going to do first is it's going to check this entire box here, and then if there's no mud-colored items in the entire thing, it'll just end. So that'll be a little bit faster than having to like move back and then middle click and, you know, and then, oh, there's no mud in my inventory. So it'll just instantly check, but is there anything? And then it'll check each individual slot. That's what I'm thinking. Yeah, let me go and get started on that, and I'll be back when I've finished it. So that was actually more simple than what I thought it was going to be. It's not done yet, but I'll show you a little sneak peek. So the program checks through each of these inventory slots, and I've made this quick gradient using, I think, Axiom's gradient tool, whatever mod does this. So on the screen you can see the part of the part of inventory that the program's looking at on the right over here, and what the computer sees on the left. So the computer's only looking for mud-colored pixels. Now some blocks will have mud-colored pixels in them, but only mud will have enough mud-colored pixels, like that. You see there where it shows up a little bit. As we get to mud, it goes pretty much fully white. I've done it! And I'm so confident of this working that we're on the actual server to end the episode. So I'm actually going to put my armor back on just in case I fall off. I'm confident, but not that confident. So I've done the setup here, so just a boat which is perfectly facing this way, and the 2 trapdoors. So if I look down... Oh, I need mud. Yes, and I went and got this shulker box full of mud. So I'll put the mud in my hand, jump on the boat, get in it, shift, get into position, and then take my hands off everything, then put my hands on everything just to press 3. So this line, it should be fine, should just place it like normal. Oh. What a good start. Yeah, for some reason it has been messing up a little bit on moving forward. Oh, what? I'm not actually sure what's going wrong here. It seems to be correcting itself. Oh, wait, what? Is it the shield? The shield might be messing me up. It might be quite close to the jungle wood color. I don't know. So I've just done a lot of testing, and at first this not working really confused me, because initially I couldn't see anything different from my test world where it was working perfectly. I have found that yes, the shield, which I've taken off now, color is too close to jungle wood. So it can trigger the too close to the wall and at the wall code. To fix that, I just take my shield off when I'm using the program. It also means that my program has access to more of the screen, so it's got more data, so it's better at detecting when it's actually at the edge. The second thing was, even with my shield off, it was detecting the edge in the middle of the platform, and sometimes not detecting the edge, and I would just fall off. To fix this, I actually found a bug in my code. Pretty much, you know how I said it was detecting the edge by detecting how high the pixels go rather than how many there are? Well, what I found was that for some reason some jungle plank colored pixels appear in the correct position when I'm in the middle of a row, and triggers the almost there or at the edge code. To fix this, I made it so the code only triggers when the jungle colored pixels were detected at a certain height and there was more than a certain number of them on my screen. I think for the falling off, I think there might have been something else in there where it wasn't properly detecting something, but it kind of just stopped when I was working on everything else, so I think that's just maybe another bug that I fixed unintentionally. Now the code on if the program's at the edge of the screen got a bit confusing, so I wanted to show off a technique that I like to use when there's quite a complex condition that needs to be met. Now this is going to look confusing to some people, and the only thing I can say is I'm sorry. So these are the conditions for the code that moves the player sideways. FP is the first jungle plank pixel, or the height of the jungle plank's pixels on the screen, and NP is the number of jungle plank colored pixels on the screen. So the code should move left or right if there aren't any jungle plank colored pixels on the screen. That's what this means. So if this equals null, that means there are no jungle plank colored pixels on the screen. Oh, it's difficult to say. But also, if there are, if the first pixel is greater than 3000, and if the number of pixels is less than 150,000, we should continue moving left or right because we're not at the edge yet. So this last part just says if the code should run or not, and I'm using zeros or ones to say kind of true or false. So that this is a 0 means that this condition isn't true, so there are jungle colored pixels on the screen, and this being 0 means the code stops moving left or right. A 1 means that the code does move left and right. I then wrote out all the possible values of each of these, so starting off with all the conditions not being met, so they're all 0, and then eventually down here when all the conditions are met, so they're all 1. So this first line, this means that if there are actually jungle colored pixels on the screen, if the jungle colored pixels appear at a point which is less than 300, and if there are more than 150,000 jungle pixels, that means we're at the edge of the screen, so we do not continue moving left or right. So I wrote that out for every single combination of these and exactly if the program should run or shouldn't run in each of those conditions. And then I went and removed the redundant conditions, like if there are no pixels on the screen, then it doesn't matter about these two values because there aren't any pixels on the screen, so these two values aren't going to exist, so it should always run. We should always move left or right if there are no pixels on the screen. This then helped me understand the problem better, so I could write code that only ran when these conditions are met. So now it's all working and I can show it off. So if I just get some in my hand, get into the boat, get out of the boat, get into position, press 3, and it seems to be working completely fine. Now there is still a problem with this. Oh, and there we go, and it just got some more mud in its inventory, and I'll do that again. Assume here. Oh, don't know if that was a little bit of a mistake. I don't think there's much I can do about that, but it just missed out one. It maybe will be fine. Yeah, it's gonna be fine. But it was just like just in the wrong place there, where not a condition I've ever seen before. So I haven't got anything in to really stop that. I guess there's not really much I can do to stop that. I think with everything where it's like that, where it kind of goes wrong and misses one, it's just the way of stopping it is to slow down the program to the point where it's unusable, where my character's moving so slow it's unusable. So it's like, yeah, it skipped one, but really, what do I want more? Do I want the program to actually help me out, or do I want it to be accurate? And there we go, the program has ended, and just one row back from the end. But if I just go like this and go and fill this in, and then I go and just boop, then it works! It works! Woohoo! The other thing I want to show, I'm actually going to collect this mud, because I'm running out of mud through doing all this testing. The other thing I want to show off is what happens when it runs out of mud, when there isn't any mud in the inventory, because we've just done it where I have enough mud to fill the whole platform. We haven't done it where maybe I just have a stack or something like that. So let me go and get that situation ready. So there we go, I just have a stack in my inventory. There we go, it gets to the end, it looked in the inventory and then it checked the entire inventory all at once, saw there was no mud in there at all, and then stopped. So that's really helpful if I only have maybe like a stack or 2 stacks I just want to get down. I also wanted to show that this program does work on the other layers. Is that a creeper down? Is it? What are you doing? Whoa, that was lucky I saw you, wasn't it? So I'll do kind of a time lapse of just me going down to each level and showing it off. I will like to say that this doesn't work at night time though. It just gets too dark that the program just can't see the colors. Yeah, but also like there's no reason why I would be using this when it's dark. It's really, this place is really dangerous when it gets dark. It's not very well lit up. But yeah, let me go and show off it working on these different levels. Okay, so that was pretty good, as you saw. Most of the time got it within, I think it was like 1 or 2 at the end. That last one was just 3 back from the end. I don't know why I just went and collected this up. I don't know. But I didn't have to do that for the last one. There were some times when it was moving this way, it would go a little bit too far and then end up hitting the wall. So I did just have to kind of move it and like just press D or press A if it's that side. So that happened a few times. Not too many, like throughout the entire thing, it maybe happened twice, something like that. There was also, again, very few times, maybe 2 or 3, it would come to the wall and then just not detect the wall. And so what I did was just move it like this, just backwards and forwards until it eventually did. So these are maybe just little things that we need to go and fix in the improvements video. But apart from that, it did very well. So that's the end of the episode. If you have any suggestions for future episodes in this series, I would love to hear about them. If not, and if I don't think of any more, we're going to be improving our previous designs next time using all the things I've learnt from this series. And if you try out anything like this yourself, also share it with us. I, and assume others watching this video, would love to know. Also, I want to improve these videos, so if there's anything you dislike or think I could do better, I would love to know. Oh, and I'm on Blue Sky now, so if you want updates and a bit more Bobby-War, that's where you should look. There's a link in the description. But anyway, that's it, and we didn't explode or get attacked by a camel, Dave. So good. Wait. What's that? What? No! 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 What? What? Dave! Dave, why? Why did you do this? No!